Hello everyone, this is Bradley. Starting from today, I will talk about this blooming flower using animation nodes. I highly recommend you to watch the demonstration so that you know what kind of functions that you may achieve at the end of this tutorial. I don't know how many parts of this tutorial will be, but this may not be long because it's actually simpler than what you have seen from the demonstration. What I want to point out is that in the demonstration, I've made an automated mode plus a manual mode, which increases this node tree about 1.5 times as large as it should be. Eventually, I think I may make this tutorial into two parts because there are some important points to mention when you want to automate this animation. But besides that, I think I'm going to make a manual part in this tutorial. So the first thing that we need to do is basically model our petal units. There's not many things that I can talk in this case. The point is that you can really model as you wish. So I'm going to basically do in my own ways, which may not be the best, but it just works. So be that, and I'm going to create a middle cut. Then something like that should be sufficient enough. For the loop cuts horizontally, just add 6, should be sufficient enough. Then I'm going to rotate that to 90. And I'm going to apply it, scale, and apply the rotation. The reason you have to do that is because otherwise the simple transform won't work very well. I actually do not really know this function very well, but it just works. You can actually test more by yourself. And for the second band, I'm just going to make it Z so that it rotates in such a way. So now it's kind of folding in such an axis. If you can see what it happens. I'm cleaning the numbers. Next step is add a subdivision surfaces. And I'm going to basically take it down a little bit so that the button touches after the subdivision surfaces. And I think this is basically done for our pedals. You can definitely do a much better job, I suppose. Shaded smooth should be enough. So let's start to do with the animation node part. So when we go to the animation node, there are several nodes that I need. One is distributed matrices, object instancer, object transform output, and the loop input. So I put these vectors into instances, and within this loop, I'm going to create an object list and a vector list. And I need to put the objects into objects, vector list into location. Select this loop node, hit W, and create invoke node. So there is a subprogram, and we connect object to object, vector to vector. After this moment is simple. So if we select the object, then it will create 6 instances, and if I change the iteration to 1, then I have objects placed on a grid. But I do not want a grid, so let's make it a circle. So change the amount to 6, radius, just a decrease as you wish. I also need to activate this copy for object. So partly it copies the name, and then it also copies modifier and many other settings. So let's first just name that a petal, and copy it again. So the name will be copied along with its modifier. Next thing I want to do is I want all these petals aligned properly. So to do that is pretty easy. Just direction to rotation, and put this vector list to direction, and ruler rotation to rotation. Set the axis to Y, it will be fine. Later on, we want to rotate all these petals. So let's add a ruler math. And if we change the X values, then it also changes. After this moment, it's fine. So this is the kind of basic setup we can have. If you know about the animation nodes, there's another way to create a loop subprogram. Is you select the node and hit W and loop through objects. Let's change its color so that it's easy to distinguish. But it will generate a iterator. So the difference between iterator and a parameter is in iterator you input a list, but for each time you run a loop, it will only input one element from the list. But for parameter, you input a list, but it will stay as a list within the loop. So this is the difference. So why I'm using a parameter instead of iterator in this case is because the principle of this modeling is that as I'm increasing the iteration, I'm going to put different petals stacking on different layers, meaning that they went to a different location so that you can see a gradation of blooming flower as you have seen in the demonstration of the rendering. So this is the principle. But you can also see as now I'm increasing the iteration amount, nothing has been changed because the maximum amount of object I'm working with is still 6. So let's firstly increase the iteration while also increase the duplication. What I'm going to do is get a viewport input. I'm going to change the value to integer. I named that as vertical. And I'm also putting other values back. Name the amount to circular, radius stays as radius. The reason I'm using a viewport input, as you have seen in the demonstration, is one part is I'm allocating all these parameters into one place. Other cases is as the tree grows large, I can change all these values just in viewport without going to a gigantic tree. And to change the instance amount, I'm going to use a float math. Vertical goes to A, circular goes to B, and change the instances. And the vertical number is also the number for the iteration. But up to this moment, still, there's nothing changed. It's because each time, although we run this loop for several times, you can see the iteration turns to be 2. But each time we're still using the same vector list throughout. So even if we have 12 objects, they went to 6 locations. So making them to run to different locations is simple. You just add a vector math. And I also need to combine vector. I'm going to input this index to the Z socket because the index will change each time for a loop. And the index always starts from 0. That's the point. If I plug this into these values, you can see our petals has been lifted up, but still we only see 6 petals. Why? It's because if you take a look with our object list, it's actually the whole 12 lists. Meaning that for the first time we run this loop, all these 12 objects will be assigned to 6 locations. determined by these distributed matrices. And for the second time we run this loop, although we change the values with this index, but we are still inputting the same 12 objects, and all this information will overwrite the previous result. So to solve this problem, we need to slice this list. For the first time we run this loop, we only affect the first 6 objects, and for the second time we run this loop, we will affect the following 6 objects, and so on and so forth. To do this, we are going to use a sliced list node and set the type into length. So what's the length? The length is basically the circular number we have. So we take this into integer and name that circular, and I plug the circular into length. Object will go with into list. But what's the start? Start is basically a index times the circular. Because the index always starts from 0, so the first time we run the loop, the index starts from 0, and the second time we run the loop, as the index goes to 1, the circular stays at 6. So we do everything, then the start will be the element which has an index of 6, which is actually the 7th object within this loop. This sounds confusing, but if you really think about that, it actually makes sense. So if now we take a viewer, you can see we have only 6 objects within this list. And we use this list instead of object, then instantaneously we see a gradation occurs. And these concepts will be effective for all the following animation that we are working with. And before that, I want to have a regulation of this index. So let's take a float math and set the parameters, and name that as vertical distance. So by changing this vertical distance, we can change how much they will differ between layers. And the same principle will apply to the rotation as well. So here we have a value to control this rotation. And to set the gradation, it will be basically the same. So let's combine let's get a Euler math and use the scale. Index goes to scale. So now we also have a gradation of the rotation as well. Next step, let's do a gradation and I'm basically doing the same thing. And this time I'm going to take a rotation and take this rotation just to another numbers. The next step is to effect its scale. Basically, it's just the same concept throughout. I'm going to unname the scale, put in these values, putting these values into a vector math. Let's name it a scale. Put the scale as 1. And let's change the scale to 1. in this case, everything has been disappeared because the index starts from 0. So if we just float mass +1, then it will basically be fine. So this is, so up to this moment, this is good. So I'm just going to change the OD index to +1. And you can tweak values by yourself essentially. And I'm going to plug all these values back to the viewport input so that it's easy to affect them. So now if we just take a look with the fact that if you increase the vectors, things will change as well. And this already looks, although this does not look like a flower, but it looks kind of cool shape with gradation. So the next thing I'm going to do is to have the rotation across the layer. And to do that, you might firstly think to add a rotation on the axis. But actually, it generates something interesting, but it's still not what I'm looking for. So to do such kind of work, instead of working with rotation directly, I'm actually going to change the vector. Because it's the vector which eventually affects how these petals aligned to the center. So I need a transform vector node. Effect vector. So it asks for a matrices, so you just input a matrices. And put the matrices in. And now if we change the rotation, then instantaneously gradation occurs. And I can directly plug this rotation back, but to simplify our viewport panel, because we're only affecting the z-axis, so I'm going to use degree and only plug the z back to, so I'm going to call it the rotation layer. And the rotation layer will be plugged back to the viewport input. Up to this moment, this part is basically done. So then next step is I want to effect all this modifier, because earlier we created a many modifier. Is because I want to fold these flower petals to cause a kind of balloon animation. So how can we actually use animation node to affect all this deform? We need to use a node which is called object attribute output. And I need to plug this object back. And I need to right click this deform angle, right click copy data path, and Control V paste. So if I just input a float, so you can see the folding occurs. And if you're looking for a gradation, then you basically just need to repeat what we have done earlier. We have the index, and then we plug it back to, and I call that vertical bending. And put this vertical bending back. So if I just set a values, you can see it actually runs rather weird. So I'm going to reverse this into divide and put the index at the bottom, so that the larger the index, it will fold less. So now if I increase the values, now I have a kind of balloon flower. So if I reverse that, I have a balloon flower. So this is basically the principle. I think this is basically finished. You definitely can do with another setting as well. So goes to blending, copy data path, objects, and basically do the same thing. I name it a horizontal bending. You need to be careful, this is very sensitive. So now if we take a bending, it actually looks kind of rather weird. But this is just a kind of idea you may or may not. This is just a kind of idea that you can do. You can see whether you would like to do this or not. Let's set that to multiply. I think this is how it should work. Something like that. I mean, you can tweak all these values later on and different calculation. So I think this tutorial has been done. Just to be aware, this petal is the only part that's you need to model by hand. And you can definitely change the geometries as the time goes. So yes, I think that's it. Definitely you can do more things. Like you can even get a float mass with this index and divide certain numbers, like divided by 10, so that the gradation size can be decreased as well. Now it becomes a more interesting flower. So really you can do a lot of stuff with these techniques, and you can organize this tree better later on. And I'll probably do the automated part as well later on. But meanwhile, I may also do other tutorials. So anyway, I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.